But today's discussion is going to be around climate change. And a couple of words to preface this. I mean, we've had a lot of discussion around sustainability here at the college in the last year or so. One thing that's been kind of nagging and tugging at me is this idea around climate change and what it means for sustainability, particularly here locally. And I think it's all the more pertinent to have a discussion on climate change given the fact that politically we are seeing fewer and fewer discussions about climate change. And in particular, the Obama administration has chosen to eliminate climate change from its environmental dialogue. So I think it's more appropriate to have this kind of discussion, and I'm really pleased to have my colleagues here to discuss it, and from a variety of different perspectives, and hopefully from this we'll be able to at least understand climate change, some of the science of it, and what impacts we can expect locally, and maybe put this in some sort of broader perspective of what this means for going forward as a society. Thank you. Guys, Mitch, I'm going to start us off with the science.
Oh, do you want just the format? Do you want me to give the full thing, or we're going to do the introductions first?
I think let's give some introductions, and then we'll go back to Mitch to start us off, and then we'll open it up to it after each of the panelists have discussed. We'll go to a Q&A.
My name is Mitch Colgan. I'm the chair of the Department of Geology and Environmental Geosciences at the college. And before coming here, I had a checkered past. I worked for Shell Oil and for the U.S. Geologic Survey, part of my job was looking for oil in Alaska. So you may have heard that it takes a long time to develop oil, so I was on the project that Shell just stopped drilling for up in the Arctic Circle. So that's my perspectives from there. I've worked on coral reefs, looking at El Nino, looking at climate change through geologic processes, as well as looking at more localized events. I was on the Mayor's Environmental Committee dealing with energy and looking at how climate change would affect the Lowcountry, specifically Charleston.
My name is Seth Pritchard, and I'm from the biology department. I have a checkered past too. I used to work for the government, which I'm kind of ashamed about.
During the Republican administration? Yeah, I can see that.
So I've spent about the last 16 or 18 years studying the effects of elevated carbon dioxide levels on how plants function. Plants in managed ecosystems like cropping systems, agricultural systems, and also plants in forests. Recently, the climate change experiment that I was working on for about 15 years was decommissioned. So the Department of Energy pulled the plug on it just as the ecologists were getting excited about many of the data that we were collecting. And so the Department of Energy decided it was time to pull the plug on this experiment and spend their money somewhere else. So that was big controversial. So there was some argument back and forth in the press, but that's how it all worked out. But I'm still working on effects of elevated CO2 on various plant processes. Particularly interested in how carbon flows from the atmosphere through canopies and forests and into the soil.
I'm Hettinger from the philosophy department, and I have a totally pure past. I've never done anything wrong. It's because I have no power. I'm just a philosopher. I'm just talking about ideas. My area of specialty is environmental philosophy and environmental ethics and environmental aesthetics. I'm teaching an environmental philosophy course right now, and we just finished a unit on the ethics of climate change, and so I'm going to be talking about those ideas.
Well, so let me begin. One of the things that we're confronted in society is trying to understand climate change. And with the idea, and you've heard this in the news, you've heard this in discussions, we're looking at a natural cycle. Climate change is natural and normal processes that go on. And we all have to go, oh yeah, sure. But the questions that we deal with is crucial is to understand the rate of change, the amount of change that's going on, and what are the driving forces behind those changes. And when we look at it, we can say that we're looking at changes of a degree, 1 degree global temperature change, which isn't very much. That's global. And so we go, okay, let's calm down. It's not very much. But let's look back in time. 18,000 years ago, back when, this is something we had my colleagues Leslie and Scott over there studying this, is that the sea level dropped to the edge of the continental shelf 18,000 years ago. The ice was over New York City. There's 3 kilometers of ice sitting up in Canada. That's 18,000 years ago. For geologists, that's nothing. And what's driving this? Well, what we find out is that there is a driving force looking at the changes in the Earth's orbit and the distribution of heat from orbital changes. Well, when we examined those changes and saw this huge effects that are going on, a 1 degree change occurs in over thousands of years. When we're examining the changes that we're looking at, a 1 degree change will occur within your lifetime. Fundamentally different scale of time in which we're examining the changes that are taking place. So it's important to recognize them. Well, let's just go back to without humans. So we have a world without humans. Or we could have a few humans, but they're all ethical. We have no oil, we have nothing else, just ethical philosophers are sitting around. And with that population, it must be very small, with that population, what we saw is that we were reaching a peak at about 1,000 years ago. We would have reached a maximum. Or actually, it's 5. Yeah, I can't remember the exact. It's within 1 to 2,000 years ago. We reached a time in our history based on the orbital parameters to finish the highest part of our warming cycle. Because the Earth during this stage goes through an ice warming and then goes to a cooling cycle. Well, if we were to just take that imprint, we just keep looking at it, right now we should be talking about the philosophers we sitting around going, it's getting cool. Because that's the trend. That's the overall trend, is that we should be looking at a cooling trend. Well, we're not. We're looking at a warming trend. And we see at this point the fingerprints of humans in the sense that we begin to start burning fossil fuels. In the past, what we saw when we looked at the changes, that when we look at the changes in the Earth's orbit, the physical forcing factors that cause the ice to advance and retreat, what we found is that carbon dioxide was the trailing factor. In other words, the Earth's orbits change and the glaciers begin to form, and then CO2 begins to drop as the Earth cools. So that's our normal pattern. Well, now we're going to a pattern where we should be cooling, so that's the orbital forcing pattern, we're beginning to cool, but we add another component. We start burning fossil fuels. We start utilizing fossil fuels. We start changing the landscape. And as a consequence, we start pumping in CO2 and another gas called methane into our system. As we pump more of these gases into our system, we see a reversal of the trend that we should see under natural processes, and that's we begin to warm. And we see a slight steady warming until the 1960s, and we begin to really increase the CO2. And then what we see in the last 10 to 20 years, the highest global temperatures that we've seen within historical records. We see a significant change taking place over a relatively short period of time, because the climate change that we've experienced before humans takes place in terms of thousands of years. We're talking in terms of tens and hundreds of years, very rapid change. So the rate of change is crucial. And we have the power, by looking at the chemical signature, to prove that it's a human impact. We can look at the concentration of isotopic gases, C14, and C12, C13 ratios, and we can prove that it's the burning of fossil fuels that are causing this elevation of temperatures. And the last thing before I turn on is that when we look to the future, the key part is that what is the wonderful thing that I think that from geology and I learned from geology and ecology, is that systems are linked. And so as we begin to prevent one system, we start changing many different ones. And one of the greatest scary things, when I look out there, one of the great scary things is there's a hell of a lot of methane sitting in frozen ice up in the Arctic tundra and in the shallow seas. And we're already beginning to see that as the sea ice begins to melt and the Arctic seas begin to warm, we're getting to see large amounts of methane being released into the atmosphere. Now, if we project towards the future, and we haven't done a good job of modeling sea ice melting, and we haven't done a good job of modeling methane release, if we start looking at large volumes of methane being released, you can go from a stable point to a catastrophic point within a matter of a few years. I mean, we're at what's called a tip, that you have a potential for a tipping point, which we don't quite understand what happens at these stages. We've not experienced and they're modeled, but here you see this change where as you begin to warm, you're changing the Arctic system in such a manner that you can release large volumes of gas and change the whole system. And this has become scary. It becomes our responsibility to understand the global change and its factors and see if we can depoliticize it just a little bit and have a real conversation about what's actually happening. So,
Well, I guess I thought it'd be a good idea to start with something local. So we're on the ocean, so we ought to think a little bit about what the likely consequences of climate change will be for our ecological systems that set next to the water. So salt marshes are important for us. They provide lots of ecosystems.
Accepting the scientific consensus that climate change is real, it's causing serious problems that we need to address. Unless we're climate experts ourselves, it just makes no sense to reject this consensus. It would be like saying, well, I don't believe that there are these plates underground that are causing mountains to rise and earthquakes. I just don't believe that. And that's just, that kind of thing is totally, I mean, how can you do that unless you're somehow a geologist who can give an argument? So the ordinary person has to take the scientific consensus. The only way out of that, as far as, you know, and that's where I'm at. I don't know anything about, I mean, I know very little about global warming, really. I can't, but the consensus of scientists are telling it's real. So what is this, believe in it? And, you know, the only way out is to say, well, be skeptical because you think, you make up a conspiracy theory. You say, well, all these climate scientists are getting paid to, you know, they get grants from the government or grants to do this research. And that's why they're saying, you know, that, you know, there's a lot of money in climate change research, and that's why they're saying it's real. And I think a lot of people do think that, at least the climate deniers. And I just, anyway, I think of that as a conspiracy theory, kind of like the, you know, the UN and helicopters coming over us. They're trying to take over the world, and sort of on that level of rationality. Okay, so that's a little bit about why we should believe in climate change. That's the right phrase. In terms of ethics, I have 4 different topics I want to quickly address here. One has to do with justice between the rich and the poor, justice between current and future generations, justice between humans and non-humans, and then human arrogance. Okay, so in terms of the first one, I think there's injustice between the industrialized world and the developing world. Basically, the rich have been stealing from the poor, and now we're going to make them suffer as a result. So the atmosphere is a common resource that belongs to all of us. That's an assumption I have. The industrialized, developed world took for itself all the atmosphere's ability to absorb greenhouse gases without causing problems. And we got rich in the process of taking more than our fair share. And we continue to now pollute the atmosphere and fuel our extravagant lifestyles. The developing world will disproportionately suffer the consequences of the resulting climate change, right? Their poverty will prevent them from doing the kinds of things we're going to do to adapt to it. They won't be able to build giant 100-mile-long seawalls. They won't be able to use use new genetic technologies to make advanced crops that could maybe survive in a warmer world. They won't be able to protect themselves from diseases. So they're going to suffer disproportionately. And additionally, to prevent further destabilization, people are telling the developing world they're being asked to develop without using the cheap, dirty carbon fuels that led the developed world to get rich. So what does justice require here? It requires that the rich compensate the poor for the theft of the atmosphere. It requires that the rich fix the problem that we created. The developed nations broke the atmosphere, and we should fix it. In terms of practice, this means industrialized nations should fund the extra costs that poor countries will have to bear to develop without greenhouse gas pollution. We should pay for developing countries to adapt to climate change that we've caused. And we need to quickly wean our own economies off this carbon addiction. I think a fair proposal for the future is equal per capita greenhouse gas emissions for all the world's people. So everybody in the world, we find whatever level of greenhouse gases we can put out that isn't going to mess the planet up too much, and we divide it equally among all the world's people. Right now, although China is the greatest CO2 polluter at the moment, and will continue to be, we in the US emit 3 to 4 times as much per person as they do, and something like 12 times as much per person as India does. So this is going to require significant cutbacks in our release of carbon dioxide and other greenhouse gases. Okay, so that's the rich-poor injustice. In terms of injustice between generations, present generation is endangering future generations. To support our way of life, we're passing off the dangerous consequences of our actions onto future people. Now, you can justify imposing maybe risks on yourself, but imposing risk on others is a completely different sort of thing. We're imposing enormous risks on future generations, on our descendants, and these people are innocent. They didn't do anything, they didn't cause this problem. They didn't do anything to deserve it. They're totally at our mercy. They have no effect on us today, so they can't make us stop. And so we're inflicting danger on the innocent and defenseless peoples that will come in the world, 50, 100, 200, 300, 500 years from now. What policy comes from this? I think we should leave all the remaining carbon in the ground. This is not to waste it, as the drill baby drill crowd would seem to have us believe. It'll be there for future generations, and they can use it once they've figured out a way to burn carbon without causing problems. So, why think, in addition to the harmful effects of our using it today, since we can't do it harmlessly, why think we get it all today? Why not let them have some of the carbon? The third injustice is between species. Climate change will involve humans inflicting serious costs on non-human species. We're going to drive species extinct. Consider the polar bear who needs this Arctic ice. And I think we're going to cause massive die-off of individual animals and plants as well, who won't be able to adapt to a quickly changing climate. So we have obligations to non-human species with regard to climate change. And the final point I'll make has to do with human arrogance and hubris. I don't think we have any business destabilizing the Earth's climate. No business adding additional human fingerprints to all the world's ecosystems, which climate change is doing. That's the kind of idea McKibben has us realize. It's a kind of Promethean God playing. We're stepping out of our proper role. The solution that people often propose, geoengineering, is just more of the same. And just as an illustration, if we spray sulfur particles up into the stratosphere to try to block the incoming sun rays, we're going to change the color of the sky. The sky won't be blue anymore. And I just think that's a symbol of humans doing stuff they have no business to do. So it's kind of arrogance. Okay, that's my spiel.
All right, let's open it up for questions. I always have something.
You said there was methane under the ice cap. What created and caused that to accumulate there?
It's not under the ice cap, it's in the tundra. It's from the organic decay. And so when the organic decay of the grasses is taking place, the plant material takes place, methane is one of the byproducts of anaerobic decay. And so it's locked in there. You see that in the seas. We have a huge methane storage of methane hydrates along the continental shelf. And so what we begin to worry is that as you warm, either in the oceans or on land, what we've seen, especially we've been monitoring methane release up in the Arctic, is that we're seeing a large increase in methane coming from the ground as the temperatures begin to rise just slightly. And as it does, the permafrost depth is you're seeing this decline in the permafrost depth. And as that thing declines, gas is being coming out. So we're seeing major changes in that because you see it as the ice begins to melt, the gas is being released. And we find it, you can see it on satellites now. You can measure the methane release in satellites, and you can also measure the seasonality of the methane release is very nice. As during the summertime, you get this big burst of methane release as the temperatures begin to warm in the Arctic.
You may want to talk a little bit about the global warming potential of methane versus carbon.
Okay. The important thing is that what you look at for every CO2 molecule that's released is you give it one warming value. For every molecule of methane that's released, it depends on how you calculate it. It's about 23 to 25 times. So you have the concentration of methane in the atmosphere is very slight, and it's short-lived. But if you begin pumping up enough, you begin to see a big change. And what you're looking at is some of the models that methane is becoming an increasingly important gas, which is causing a warming effect.
I've got a question about the salt marsh research. Just kind of where the state of researching salt marshes in relation to climate change is. How long have we been seeing the diebacks, and what kind of specific studies have taken place linking salt marsh diebacks to known global warming impacts like sea level rise or carbon emissions or something like that?
So the salt marsh dieback literature kind of sprung up in around 1990. I mean, some of it was going on long before that, but it became really popular, I guess, as the phenomenon became more widespread. There is a big literature on salt marsh dieback. So a lot of papers have been published trying to figure out what's causing it. There is no sort of silver bullet. And the best explanation that folks can come up with is that there's sort of a synergism between a lot of different environmental effects together that's causing the marsh dieback, which can include changes in salinity. So as salinity concentrations in the water within these marsh systems increases, then the productivity of those plants decreases. So if you have if the plant's under more salinity stress, for example, and then you have an herbivore such as the purple marsh crab that nibbles on the leaves, then the plant is less able to recover after that herbivory event. That's going on. There's a nematode that's been identified that can be problematic. As I said before, there's a fungus that's problematic. There's a giant literature out there. You can kind of poke through it, but we still don't have a very
humans to basically buff up the sequestration potential?
That's a good question. Right now, what's happening is a lot more nitrogen is working its way into the salt marshes, and that can be good because it promotes, it absorbs a lot of the nitrogen before it gets into nearshore waters. But what it does is it causes the growth form of marsh plants to change. So when you give the marsh plants more nitrogen, they grow a much larger, more robust shoot system, but their root system may get smaller. So there's some concern that may cause some destabilization, some erosion problems, things like that. So it's difficult to predict what effect increased nutrients are going to have. There's some thought that we need to create sort of buffer zones, inland buffer zones, where marshes can sort of migrate up the beach as sea level rises, sort of give them room to migrate. Whether or not they'd be able to migrate fast enough to keep up with sea level rise, I don't know.
I just had a question with regards to overall plant productivity. You're saying that you're trying to figure out how CO2 is affecting productivity currently. Is there a way to go back and look at fossils and isotope data to judge productivity during other periods of time with elevated CO2 or not elevated CO2 system based on?
Yeah, folks have used dendrochronology some. So dendrochronology is the science of studying tree rings, sort of the width of tree rings. So every year as a tree grows, it makes an extra layer of wood. And by looking at the thickness of that layer of wood and looking at the characteristics of the cells within that layer, you can learn things about the climate for that particular growing season. And you can actually, so a tree doesn't live forever, right? So the oldest tree may be 4,000 years old. So that gives you a 4,000 year window back in time to understand climates. Well, you can link that 4,000 year window to a previous window from a different tree that had already died by doing some sort of cross dating between trees. So there's a way to go back tens of thousands of years using dendrochronology to understand fairly recent climate change. Yeah.
I know you mentioned the importance of depoliticizing the issue, and I was wondering if you know how scientists or citizens are currently working to make the issue more urgent to politicians in order to make it less of a bipartisan issue.
In my area, the American Geophysical Union, a number of these institutions, we've been trying very hard to educate scientists in the way to communicate this issue to the public, because a lot of times it's odd, it's a difficult thing. Scientists in the past have been quiet and not really being, it wasn't to their benefit, let's say, to publicize, to push out into the general public. And at a number of meetings in the last 5 to 10 years at different scientific conferences, we've had a growing number of how to communicate science, how to engage people, how do you engage the community in conversations, what should your role be within the community, about how do you talk about something without being a political advocate. And so there is a concern about this, and there has been a change at least in our societies, there's been a change in the way and the responsibilities that we have, our members have, towards communicating this. And our societies have also come up very strongly with statements with regards to climate change as a fact. In fact, they cite the American Geophysical Union as a huge, the majority of the climate scientists are members, and they cite their strong support for the Earth's climate is changing, and we can speak to that. We can speak to that and speak to the variations and the complexity of climate change. Zoology doing anything more?
I might just say a little about that. I think I read the Times the last 2-3 months a story about how to make more conservative people worried about climate change. And I think the basic message was you don't talk about climate change, you talk about the effects. You talk about sea level rising, plants dying off. And you don't, I mean, if you don't just start talking about climate change, and that's the sort of buzzword that you talk about concrete problems that are happening. I think there was more to it than that, but that's all.
I got involved in the political part of climate change when I was on the Mayor's Environmental Committee. And it was a very interesting transformation that I saw. we were about to present our paper to the city council, and at that point, we began showing up at the committee were members of the teabaggers, and they started coming and they were wearing their patches with, it says, climate change, with a big red X through it. And so they were all wearing these buttons. And every time the Mayor Riley would stand up and would explain, that one of the reasons we're looking at these changes in energy standards, he used the word, was a way of decreasing the potential for climate change affecting Charleston. Boos came up. The people were booing the very fact that he used that word. And then we were sensitized to that. And other ones, we started moving away from the use of climate change as a rationale for why we were going to do it, because the political fight was too great. So what we changed in terms of our energy arguments was energy efficiency and cost. You save money. Well, as you're saving money, you become more energy efficient. From my point, we're producing less CO2, and so that's the benefit. But we didn't talk that from an altruistic, you should do this to prevent CO2, you should do this to save money. And that was the change that we had to make in the way we argued our point. But when we first started the process, it was very much the other way around. We were doing this because we wanted to decrease our impact on global change.
I'll follow up with this. Do you think that, given the political survey data is showing that in the last 2 years there's been a decline of some 10 percentage points around whether Americans believe in climate change or that it's human-induced, do you think that, given the overwhelming science of it, and yet we're seeing a regression in terms of the number of people that understand it and are supportive of policies around addressing climate change, that maybe we do need to shift the message more in line with eco-efficiency arguments?
Well, see, the thing that always amazes me, I've been involved in 2 battles, scientific battles. One is, strangely enough, when I got here, the discussion of evolution. Right? And you still have, evolution has been around for a while, and we still have people who have a political agenda, whatever that political agenda is, to deny that it's taking place. And we see it, doesn't matter what we say. And the sad part is that when you do a survey of Americans here, you have less than half American society accepts evolution as presented. In fact, you have a surprising amount who believe the Earth is 6,000 years old. You deal with things like that, there's a political, once the subject becomes politicized, the science doesn't matter, because you can always disparage the person who's raising the issue. I mean, we are godless, or in this case, Seth is a mercenary because he wants climate change so he can continue to get research.
His job security.
You know what I'm saying? That's you can always. Once it becomes political, you don't have to be rational about how you tear somebody down, and that's what you see. When you see that, I see parallels in both fights between how you fight the fight. You don't fight it on the facts. You don't fight it on anything else. It becomes emotional, and it becomes the way you deal with somebody who disagrees with you. You tell them that they have their motives are suspect. So unfortunately, I've seen that too many times.
Another question?
Have you addressed the public policy issue related to how FEMA and others have changed their stance about rebuilding after storms? It seems to me that hurricanes and storms are going to be the prime mover in terms of actually getting people off the coast or not as an impact.
Oh, we haven't talked. There was, of course, after Hurricane Hugo, we had the 2/3 law that was, in fact, that if a house is 2/3 destroyed, you couldn't rebuild. And that didn't happen very often.
Well, I mean, the rules have changed since Hugo.
Right, and the reason they've changed is because of the idea of takings. you had the idea of property rights and takings that were going on that prevented, after the Supreme Court decision, with regards to private property rights, the state became gun-shy about doing anything about restricting use or access to property.
I thought there was some statement about, well, during Hugo, if your property was more than, was damaged, that you would only be reimbursed if you spent the money on that property.
Well, I don't know, that's an insurance question, that's not a
Right,
policy
that's an
question.
insurance question, but I mean, it plays into public policy. And then I think during Katrina, what we found is if your property was more than 50% damaged, that you couldn't do anything to your property. You couldn't get insurance money to do it.
Well, that's
a pretty significant change from Hugo.
Well, I mean, the state law within South Carolina specifically says it's two-thirds, if you're over two-thirds destroyed. Scott knows more about it, if you want to speak to it, Scott.
I'm just trying to put it in the perspective of the hurricanes. Right now, we have such an economic drive in our state that, you know, the economic push behind it is overwhelms any possibility for trying to get people away from the coast. And, you know, we have a mechanism that we build our coasts now, you know, with soft solutions to doing that, renourishment. And it's fairly well established that we can do that. And so to post-event impacts of wiping an island flat and then claiming that, you know, as a public body that people can't build there, of course they're going to litigate that because it's worth, I mean, I was looking at some of the tax values in a state, you know, we want people to live there. Their taxes in some places on one house is much more than 2 or 3 of our salaries combined. You know,
Speak for yourself, Scott.
10 or 12 of our salaries. And so, you know, the balance between wanting to preserve the barrier islands in a natural state and wanting to have that economy is something that we have to decide as a public, and most of the public is driven by the economics right now. And so, you know, that's where we have that problem of, can we take somebody's property, and then if we do, can we afford to pay them for it?
There's, it's reminding me of a little spit of land down in Kiowa. And it hasn't been developed yet, but they want to develop it. And so far, they've been preventing from doing it. And I'm sure the developers, all they care about is how much money they're going to make on the houses. They don't care if it's blown over in a hurricane. But I think you've got the people who really care about the Kiowa area, you've got the environmentalists, and so far they won in that instance.
Mitch, can you clarify in answering that question the relationship between hurricanes and climate change?
That would be a tough one. There's debates on hurricanes and climate change, and that's probably one of the greatest areas of uncertainty. Except for the argument is that we should have stronger hurricanes, not more frequent hurricanes. And there's been a slight pattern change that you can see that. But the statistics aren't in. The idea is that you begin to warm in the equator. The equatorial oceans begin to warm. It provides more heat energy, and therefore you have stronger hurricanes. But it's modeled nicely, but we haven't quite seen that yet. But that's the concern, is that we'll have more Katrina-type hurricanes down the line.
Can you all touch on adaptation measurements that the Lowcountry can take in order to prevent or lessen the impacts of sea level rise, saltwater intrusion, marsh buybacks? Maybe official in your meetings with the mayor, did adaptation ever come up, and what's the plan?
Oh, that was lovely. We had an adaptation plan, and essentially we were going to build. The only way they can do it is sea level begins to rise. You're going to have to build diking around the city, and what they're looking at, and it was the Citadel Architectural Group had the assignment to measure at each level what it would take. And so they presented their plans for changes in sea level rise. And you get to a point where you retreat around like James Island and these places because you won't going to preserve those. But you have to preserve the historical place downtown. And so you begin to dike around that. And you have a situation in which the peninsula becomes below sea level in a diking system.
Just to follow up on that, did you see any cost estimates attached to anything like that?
No, but it was just a strange thing because that's the point is that as sea level rises, you have very little choices because we're not yet adapted to living underwater. So you either have to retreat for this rising sea level or you protect yourself from rising sea level. And you look at it in places in Europe, the Netherlands has a series of diking systems that protect them from doing that. Their coastlines are different and they have that ability to do that. But here we would have to preserve certain places. Or you have the other idea is you move Charleston to Somerville, which would not be great, I don't think. I mean, that's what you have to do. You have to decide what you're going to preserve and what you're going to But in the rising sea level, from a human point of view, you don't have a lot of change. You can't, unless you prevent by diking, you don't have a lot of opportunities.
Our resident climate skeptics.
You said there was evidence of ice melting in the Arctic. I was just wondering, I just recently saw a graph of the Antarctic ice growing. I was wondering if you think that graph is completely bogus and if not.
Depends on what type of measurement you're taking. If you're looking at absolute volume, that's different than looking at areal extent. And it's not looking at that study is not for all of the Antarctic. That's for one section of the Antarctic in which there's a slight growth, but the whole thing isn't doing that. If you want to look at something that's more scary, if you want to look at ice, it's very well measured, which we have a lot of history on, is NASA has been monitoring for the last 30 years using LiDAR data over Greenland. And we can see changes that are happening on Greenland in terms of the absolute height are measured in terms of centimeter height differences that you can measure in the ice. You can see the changes happening there and volumetric changes that are going on. You also can see that the ice in some areas of Greenland, it's kind of fascinating, is growing. Well, the reason it's not growing because it's stacking up more ice. It's growing because it's slipping and moving out to the sea. And once it moves out to the sea, what's really fascinating is that once you begin moving out to the sea, then you get big blocks falling off. In Antarctica, the surprise was, and still is that as the process of the ice shelf, and so an ice shelf is an area which is of freshwater continental ice that's actually slid over the ocean water. And this now is being calved off, and you get these huge amounts of big ice, size of Connecticut and Rhode Island, that are now floating because of this calving process that's taking place. And so you have this expansion of ice, aerial expansion of ice in some ways, but volumetrically, the total volume of ice is declining. And your concern should be volume, not aerial extent.
Can solar variations be a thing about it?
Solar variations account for 1/10 of 1% of the change in temperature. But solar variation is a part of it because the thing is that I think the most important lesson, and it was just listening to Seth talking about why you have